So hi guys, today I'm going to tackle the chapter 3, the summary of the chapter 3, titled Network Protocols and Communication. So for the first in the chapter 3, so it is a network that connects us. So people communicate online from everywhere. So conversation in school, um, and in different places and other things. Um, so like it's spill into instant message, chat sessions, and online debates. Um, like online debates that continue at school. New surveys are so New surveys are developed daily to take the advantage of networks. So rather than developing unique and separate system for the delivery or of each new service, the network industry as a whole has adapted a developmental framework that allows designer to understand current network platforms and maintain them. So at the same time, this framework is used to facilitate and development of new technologies to support future communications need and technology enhancement. So let's proceed. So communication fundamentals. So a network can be as complex as devices connected across the internet. Or as simple as two computers directly connected to one another with a single cable and anything in between. Network can vary size, shape, function. So, however, simple having a wired or wireless physical connections between end devices is not enough to enable communications. So for communication to occur, device must know how to communicate. So this is the human communication. So as you can see, we have here message source to transmit, which is the signal, and then transmission medium, signal, which is the receiver, and then message destinations. So it's also like in the computer but in human communication. So it's also um, um, like in the communication. So this one. So this is the computer communication. So as you can see, it's also message source to transmitter, transmission medium, and receiver, and then destination. So it's almost this. So it's the same. For the next one, so we have rule establishment. So before communicating with one another, individual must use establishment rule or agreement to govern the conversation. So um, so the protocol must account for the following requirements, which is an identifier and sender, common language and grammar, speed and timing of delivery, confirmation or acknowledgement requirements. So that's the protocol that must account for so for that following requirement. So as you can see in this, you have the protocol is message encoding, message formatting and encapsulation, message size, message timing, message delivery options. So it's all in the protocols. So for the next one, we have we have message encoding. So one of the first step to sending a message is to encode it. To en- to encoding. So encoding is the process of converting information into another acceptable form for transmission. So decoding reverses this process in order to interpret the information. So just like in human communication, it also has a message source, encoder, then transmitter, and transmission medium, the channel, receiver, decoder, and then message destination. So for the next one, we have we have the message formatting and encapsulation. So when a message is sent from source to destination, it must use a specific format or structure. So message format depend on the type of message and channel that is used to deliver message. So the format should be depend on the type of the message and the channel that is used to deliver the message. So personal letter contains an identifier of the recipient and as a salutation or greeting, and then a message content, closing praise, an identifier or a sender. So that's all for the message formatting and its encapsulation. So for the next one, we have the message size. So another rule of communication is size. So when people communicate with each other, the message that they send are usually broken into smaller part of sentences. So these sentences are limited in size to what the receiving person can process at one time. So um, So when people communicate with each other, the message that they send are usually broken. So um, um, it um, it it is broken into a smaller part or sentences. So as I said, these sentences are limited in size to what the receiving person can process at one time. So for the next one, we have message timing. So in message timing, we have the access method, flow control, and the response timeout. So for the access method, so it determines when someone is able to send a message. So if two people talk at the same time, a collision of information occur, and it is necessary for two to back off and start again. So the two person can both talk because it can have a collision of information. So like in the computer, it's necessary computer to define an access method. So hosts on a network need an access method to know when to begin sending message and how to respond when the collision occur. So for the next one, for the flow control, so timing also affects how much information can be sent and the speed that it can be delivered. So if one person speak too quickly, it is difficult for the other person to hear and understand the message. And in network communication, source and destination host can flow control methods to negotiate correct timing for successful communication. So, like in human communication, if one person talks too quickly, it is difficult for the other person to hear and understand what she or he saying. So for the next one is response timeout. So if a person asks a question and does not hear a response within an acceptable amount of time, the person assumes that no answer is coming and reacts accordingly. So the person may repeat the question or may go with the conversation. So hosts on the network also have rules that specify how long to wait to response and what action to take if a response timeout occurs. So yeah, if a person asks a question does not hear a response within a acceptable time amount of time, the person assumes that there's no answer, because if ever you ask they ask a question and it you don't hear a response, so you're of course you will assume that that person um un, um don't answer you or something. So for the next one, we have message delivery option. So you have here the unicast, multicast, and broadcast. For the unicast, it is a so as you can see in this picture, it is a one-to-one conversation or one-to-one delivery option. So it's one-to-one. So it is referred to as so for one-to-one delivery option, it is referred to as unicast, meaning there is only single destination for the message. So that feature is the example of that. So as you can see, they that there this the that these two they they are just they are the only who is talking. So that girl and the boy. So for the next one, we have multicast. So as you can see in the picture now, they have other person. So it is one-to-many delivery option. So it is referred to as multicast. So multicasting it is the delivery of the same message to a group or host destination so it is group of destination. So it's only specific to I think for a group. So for the next one, it is broadcast. So it's for one to all message. So some protocols use a specific multicast message that is sent to all devices. So as I like that in the picture, so she talks to all that she talks to all of the person in that group. So it is a broadcast. For the next one, we have conversation protocol suite, which is the conversation protocols. So I'm just gonna add this one. So conversation protocol suite. So it one is use a common language. Wait your turn, which is for the rule um layer. So use a common language. Wait your turn. Signal when finished. So for the next one, we have the protocol interaction. So we have the HTTP, TCP, and IP, and the Ethernet. So the HTTP or the it's so the um HTTP or the Hypertext Transfer Protocol, which is in layer name in the layer application, and the TCP, which is the Transmission Control Protocol, which is in the transport, and Internet Protocol are the IP, which is in the internet, and Ethernet, which is in the network access. So as you can see in this one, we have the protocol suite and the industry standards. So we have here in the layer application that HTTP, DNS, DHCP, FTP, and the TCP or IP. And for the transport, we have the TCP UDP, and the internet IPv4, IPv6, ICMPv4, and ICMPv6. And network access, it's all in the Ethernet PVP, frame relay, ATM, and WLAN. So, as you can see in the picture, that's the protocol suite in the industry standards. And for the next one, we have the TCP IP protocol suite and the communication process. So in the application layer name, we have the name system DNS, host configuration with the BOOTP, and DHCP, and the email is SMTP, POP, IMAP, file transfer, which is the FTP and TFTP, and web HTTP. So the transport layer, UDP, and the TCP. And the internet layer, we have the IP, NAT, and the IP support, ICMP, and the routing protocols, OSPF, EIGP, RP, and the network layer, we have the ERP, TCP, Ethernet, and interface driver. So for the next one, so we have the electronics and communication standards. We have the IEEE and EIA, TIA, and ITU-T. So the IEEE, it is the Institute of Electrical and Electronics Engineer, and for the IAE, it stands for Electronic Industries and Alliance. For the TIA, it stands for Telecommunication Industry Association. For the ITU-T, it stands for International Telecommunication Union, Telecommunication Standards Sector. So for the next one, so in this figure, as you can see, so in this figure, you can see that you have the application, presentation, session, transport, network, data link, physical. So the application, presentation, session, all in TCP or IP model application, and the transport is in the transport, network is in the internet, and data link and physical in the network access. So the TCP protocol suite is, you can see in the blue boxes. So in this figure, so they are each represent a basic type of layered networking models. So we have protocol model and reference model. So the protocol model, this type of model closely matches the structure of particular protocol suite. So in the reference model, this type of model provides consistency within all types of network protocols and service by describing what has to done at a particular layer, but not prescribing how it should be accomplished. So for the next one, iOS reference model. So it has the application, presentation, session, transport, network, data link, and physical. So the application layer contains protocol used for process-to-process communication, and then for the presentation, it is a layer provides for common representation of the data transferred between application layer services. Session layer provides service to the presentation layer to organize its dialogue and manage data exchange. So and so on for the transport, network, data link, and physical. But I'm going to read it here. So the transport layer, the transport layer, it defines service to segment, transfer, and reassemble the data for individual communication between the end device. For the network layer provide service to exchange the individual pieces of data over the network and the network between identified end devices. And data link layer protocol, it describes methods of exchanging data frames between devices over a common media. Physical Physical layer protocol, it describes the mechanical, electrical, and procedural means to activate, maintain, and deactivate physical connection to bit transmission to inform a net to and from a network devices or device. Message segmentation. So for the message segmentation, it has two primary benefits. So by sending smaller individual pieces from the first one is by sending smaller individual pieces from source to destination. Many different conversation can be interleaved on the network called multiplexing. And the other one is segmentation can increase the efficiency of network communication. If part of message fail to make the destination due to failure in the network or network congestion, only the missing part need to retransmitted. So this is the encapsulation. So as you can see in the picture, you have um, data, which is in the email data segment, and transport. The third layer, the packet, the data transport header and network header. Frame, which is the medium dependent, which is the transport layer, data transport header, network header and frame header, and the bits. So for the next one is the encapsulation. So the encapsulation, this process is reversed at the receiving host and is known as this encapsulation. So this encapsulation is the process used by receiving device to remove one or more protocol headers. So the data is encapsulated at its move up to stack towards the end application. So that's all for the chapter 3 summary. So thank you guys for watching. I hope you learned and from this chapter, and thank you guys again for watching.